Welcome to Saim Studios. I'm excited to talk to you about artificial intelligence. And without further ado, let's step right into the video. Alright, so today we have a lot of things to talk about. So I want to kind of break down what AI is all about. And fundamentally, once you break those concepts down, you'll have a full-blown picture of what machine learning is about, what is deep learning networks, neural networks. And so I'm just going to break it down piece by piece, structure by structure, so that way at the end, when you know about these concepts that I explained to you, you could even talk about it and explain it to others. And I encourage that, because that's kind of where I am at. I'm trying to figure things out. I'm trying to understand. From time to time I revisit these concepts because it's a heavy topic to consume at a very short time. And it's one of those things where you have to immerse yourself every now and then, look at videos, learn about a lot of things, keep those things in the back of your mind, and kind of expand your knowledge and find ways to connect the dots. When you're in it, then you can start connecting with people, figuring out ways you can expand that. So without further ado, what I'm going to show you guys is a couple diagrams. These are some diagrams that actually helped me. Okay, so hopefully you can see that. This is artificial intelligence. The reason why I'm showing this and a couple others that I'm going to show you, I see a lot of interchange between AI, machine learning, deep learning. These concepts, they get thrown out there, and it overlaps a lot, and it's true to some extent. But when I talk about those things in the beginning, I thought it was all the same thing. But no, there's fundamentally AI is the big picture, and within that subset is machine learning and then deep learning. What is AI? AI at its core talks about the use of computers that try to mimic some of our cognitive functions within the human. And there's a lot of that relation to how our brain works. So our cognitive functions, things like reasoning, memory, attention, language, and how we acquire information to gain that knowledge within our brain. How we understand, how we identify that this object could be a box, or this is like a sunglass. So things like that. We do it so easily that we don't really think about it like it's not a big deal, But for a machine, there's a lot of calculations, a lot of data that needs to be set up in order for the machine to identify object that it's never been detected before, or it takes a set of functions that we've assigned it or labeled it, and over time it picks those things up. So that's AI in a nutshell. I want to actually show you guys a couple others. This is one. So it says AI, a program that can sense, reason, act, and adapt. These are essentially our cognitive functions that I was referring to. So the second part is machine learning. So machine learning actually focuses on a set of data, like I was saying, and the machine essentially is learning based off of a set of algorithms and information, and it processes that information to make sure what the object can be considered as. So another example of that would be this one as well. A subset of AI that includes obtrusive statistical techniques and enables machines to improve their tasks with experience, category including deep learning. So the essence of it is AI is trying to mimic our human functions, our human thought process, and machine learning has more like the computation, statistical, the mathematics behind how the machine will operate and identify a certain object. And then at its finest and at its core, we have deep learning, where it's trying to take software, train itself, it's trying to perform certain tasks, things like image recognition. There's multiple layers of networks in order to identify the object. So I'm going to show you guys like a diagram. This is kind of how our brain works, and that's why they call this like a neural network. So at its core, the machine has an input of information, and then it outputs the final result of, it could be an image, it could be an object, whatever it may be. This is essentially the process. So in between all of this, there's hidden layers. It could be multiple hidden layers in order to accurately take in data and figure out which one's the bad data, which one's the good data. And when it has good data, it tries to strengthen those networks, those series of networks. And when it realizes that it's not that certain object versus like if it's a hot dog versus it's not a hot dog for image recognition purposes, then the parts that it's not, those networks get weakened, and then the ones that images or certain pixels help to identify that it is, and those networks get stronger. And over time, this thing repeats over and over multiple times. So when I feed in the data, the more it has. That's why you get that saying where like the more I type in, like it could be auto suggestion for like spelling in your iPhone or your Android device, that over time it picks up your language, it picks up that, and essentially, you know, AI is built into that. So over time things get better the more data you have. That is that. And then the other thing that I wanted to talk about was deep learning. So deep learning is really, we talked about the layers, and then so there's deep learning networks and deep neural networks. That's kind of the same concept. What it is, it's you're programming and you're defining items and systems to exposure to a million set of data points. When there's a lot of data there, now it helps to extract that information, and now you're able to figure out that final output. So there are 4 types of learning algorithms, I would say. There's supervised, there's unsupervised, there's semi-supervised, and there is reinforcement learning. So reinforcement learning, those are the 4. And I'll talk about what each of those mean. Supervised learning is when you have labels assigned to your data. All of your data is tracked. Everything is more like planned out. So you label what those images are, and then you tell which data sets are not that object. So essentially, if I give you a set of data that this is a picture of a cat, I'm labeling it myself and then telling the machine these are examples of what is not a cat. So based on labeled data, that it takes those data set and it creates that input to output that I showed you guys right here, the input to output. So everything is planned out, everything is labeled out. Unsupervised learning is when this is the first time the machine or the system has no form of label, and it's totally experimental in the sense that there's a lot of inferring built into the function of your data set, and so a lot of that data you don't know what to do. So it's essentially unlabeled data, and you have to kind of infer and make some logical decisions based on that. So the machine or whatever you're using to figure those out figures out based on common patterns and trends, and those are kind of the networks that it builds off to create that input to output at the end. Semi-supervised machine learning is both. So it's talking about, it's a little bit of labeled data versus unlabeled data, and it takes a lot of those functions into account when it comes to its final stages. Last thing I talked about here was reinforcement learning. Reinforcement learning talks about rewards. It interacts with your environments and what happens at the end. It's based off of like trial and errors, and figures out what those trial and errors might be. So reinforcement learning is based off of actions and discoveries it makes based on errors and rewards. So when you have certain characteristics or software, it just keeps on trying. It's almost like some of the games that you've played, like Mario Kart, where every time, a certain time you fail, game is over, and then you try again. You try, and then essentially over time, it goes through the whole game, and then it figures out all the possible failures versus all the possible success. And that's what reinforcement is. So we're going to actually kind of dive deep into what AI is all about. We're going to talk about some of the power behind AI, and I want to show you guys a video, and we could walk right through. So this is a video by Google developers.
People have been tinkering, experimenting, taking things apart, trying things out. And when lots of people are able to get involved in this process and play around with tools and technology, it gets better for everyone. Recently, this has been happening with artificial intelligence, especially with machine learning. Lots of people are getting involved, exploring speech, language, image recognition, and more. And that work is being applied in helpful ways. In something like Google Photos, you can now just type dancing to find all your pictures of dancing. But if you're curious and want to play with this stuff, and you're poking around things like this, trying to understand how it all works, it can be pretty intimidating. That's why we've created a site called AI Experiments. It's a showcase for simple, hands-on experiments that show how machine learning can make sense of all kinds of things, like sound, language, music, live video, everyday objects,
drink,
even in different languages, and your messy doodles.
I see a frying pan, or whale. Oh, I know, it's snowman.
For each experiment, there's a simple video explainer by the people who made it. There are links to open source code to make it easier for others to make new experiments, and people can submit what they make. All of this is an effort to make this technology more accessible to everyone: engineers, hobbyists, students, anyone who's curious. This way, anyone can get inspired to start making things with machine learning. So come and start playing at g.co/AI experiments.
So I think that's pretty cool. It's really awesome to see progression of AI, and it's so exciting, and we use it without even thinking about it, searching for images. I use Google Photos a lot, and so it's so cool when I think about certain types of images that I'm looking for, a certain type of sound. It all comes together through AI. I want to say some of the best advantages of AI that I've noticed is through medical research. So with AI technology, we're able to quickly and accurately identify cancer cells. We're able to train those machines, and so we're able to put in so much data. They're able to quickly find out with more accuracy than some of the best doctors out there to detect cancer. Another thing is self-driving cars are coming up on the rise. And that's really something that's been motivating me, that's been exciting me. It's able to detect traffic lights, stop signs, pedestrians, people, any type of traffic incidents, like construction work, those kind of things. And it's getting more and more better because companies like Waymo, Tesla, and a couple of many others, Comma.ai, that's another really good company. So all of these things are disrupting the way AI is changing our society and making it so much more easier, so much more better. So some of the benefits that I wanted to talk about for neural networks, you can take this data, you can take complex set of data and dissect it and create some meaning. That's why we have fields like machine learning engineers or data scientists. You can take certain, you can figure out patterns and trends. Normally that it would be complex for humans to understand. And you can look at different examples and kind of create some sort of understanding and recognize objects very quickly. So I want to kind of give you guys another video essentially that that really helps to define what neural networks are and kind of how our brain functions work. So this is another video.
When you or I look at this creature, we know it's a dog. But when a computer sees him, all it sees
This is from Nova, by the way.
How do I get a computer to recognize that this photo, or this one, or that one, is a photo of a dog?
It turns out that the only reliable way to solve this problem is to give the computer lots of examples and have it figure out on its own the average, the numbers that really represent a dog.
Here's where deep learning comes in. As you might recall, it's a program based on the way your brain works.
Yes.
And it looks something like this. Here
This
we
is a
have
better
layers of
example of
sensors
what
or
I wanted to show you.
Each feeds information in one direction, from input to output. The input layer is kind of like your retina, the part of your eye that senses light and color. In the case of this photo of Buddy, it senses dark over there, light
So
over
this is more
here.
like unsupervised learning. It just takes
This
certain
information gets fed to
pixels
next
of the
layer,
image.
which can recognize basic features, like edges. That then goes to the next layer, which recognizes more complex features, like shapes. Finally, based on all of this, the output layer labels the image as either dog or not dog. But here's the kicker, and this is what's revolutionary about deep learning and neural networks. At first, the computer has no idea what it's looking at. It just responds randomly. But each time it gets a wrong answer,
information flows backwards through the network saying you got the answer wrong. So anybody who was
This is
supporting
what I
the
was talking
answer,
about.
your connection strength should get a bit weaker.
and anybody who is supporting the right answer, their connections get stronger. Back and forth, it does this over and over again. Until, thousands of images later, the computer teaches itself the features that define dogginess.
So I think that's pretty cool. That's essentially how our brain is working, and we identify objects so easily and so quickly. So that's what we're working with. And I think it's so, I could go on and ramble for hours, but that's kind of some of the awesome things that I want to show you guys. I want to share these things with you. I hope you guys enjoy it. Moving along in the video, I hope in the future, what I want to do is just dive straight into these things. I want to talk about certain topics, these modeling things that are out there with Google, Amazon, and a couple other companies that have built up the tools for developers like us. And we can use these things and I want to create projects like image recognition or work with self-driving modules and things like that. And so we'll take it step by step. We'll actually walk through a couple examples, and I'll give you guys like a hello world version of it. I'm glad you guys took the time to watch this video. I hope it inspired you. I hope through this you guys get to work on some of your own projects. If you guys have any questions, please put your questions down below in the video in the comment section. And please subscribe and support me. And until then, I'll see you guys next time. I love your beautiful faces off. And remember to keep learning, keep going, and keep growing. And until then, take care.